compare the reliability according to the current magnitude of the CC section and the CC-CV charging method. So this is the table of contents, and first I'm going to talk about research motivation, and second is CC-CV charging method. In this second section, I'll explain what is a CC-CV charging briefly. And then it's charging circuit and battery overview, and next is simulation results, and then it's CC-CV control block. In this section, I'll explain how CC-CV works, and next is reliability evaluation method and failure rate. And finally, it's reliability analysis and conclusion future work. So this is research motivation, and the global implementation of electric vehicle is increasing rapidly. And because of that, the usage of lithium-ion battery is increasing too. And meanwhile, the CC-CV is one of the most widely used lithium-ion battery charging. So following this trend, the reliability assessment is required. And so in this research, I focused on the effect of CC current on reliability. In this section, I'll explain what is CC-CV charging. CC-CV means constant current and constant voltage. It initially charges battery at constant current, and then later it charges battery at constant voltage. And this CC-CV method has several advantages. First, it can charge the battery fast with continuous current, and it can prevent over voltage with constant voltage phase. And with this, it can ensure safe charging with efficient charging. And lastly, it is easy to implementation because it has simple and basic control logic. So this is the charging circuit, and the blue box is a simple bidirectional DC-DC converter I used in the simulation. And the red box is the diagram of the control block. And this converter converts 750 volts into 420 volts. And this is the key parameters of the simulated battery. Full voltage is 420 volts, and this means the maximum voltage of the battery when fully charged. Rated voltage is 307 volts, and it's the average operating voltage. And discharge cutoff voltage is 250, and this means the minimum voltage limit of the battery during discharge. The rated capacity is 270 ampere hour, and in this case it means the battery can supply 270 ampere of current for 1 hour. This is the simulation results, and from the top you can see that as the CC current decreases from 270 ampere to 135 ampere, the duration time of CC phase increases from 765 seconds to about 6,700 seconds. And 1 C corresponds to 270 ampere. In this section, I'll explain how this CC-CV works. At first, at CC phase, the charge current is almost the same as reference current, and charge voltage is lower than the reference voltage. Both control signal is fed into the minimum block, and the minimum block selects the lower one, which is the signal of current. And as the battery charges, the voltage of the battery increases, and at some point the charge current is lower than the reference current, and the charge voltage is almost the same as reference voltage. So the minimum block selects the signal of the voltage, and this is how CC-CV control works. For the reliability evaluation method and failure rate, I used the Iicaiet Guide 2022, and this is the failure rate library for electronic components. The major factors considered in this research was thermal factors, and the 0.75 C of CC current magnitude had the highest failure rate. And this is the reliability analysis and conclusion of future work. This is the graph of reliability for 1C and 0.75 C and 0.5 C current. The time to reach reliability of 0.5 was 6.2, 5.2, and 0.5 for 1C and 0.75 C and 0.5 C current. And the MTTF, which means mean time to failure, was 9.2 and 7.5 and 17.3 each. The conclusion is that the reliability is not only affected by the C current magnitude, but it's also affected by the CC phase duration. 1C was expected to have the lowest reliability, but actually the 0.75 C had the lowest reliability. This means the low CC current causes low electrical stress, which means the increase of reliability, but also low CC current causes longer charging time and high electrical stress, which means decrease of reliability. So the CC current magnitude and phase duration both affects the reliability. And future work will focus on two sides. And first is exact thermal data. In this research, the reliability analysis was conducted based on estimated thermal data, and future work will be conducted based on actual measurements. And analyzing the effect of CC current and charging time on reliability is the second. And the relation between CC current magnitude and duration time will be deeply searched, and the optimal charging condition to reach high reliability will be found. Thank you for listening.
Thank you very much, Mr. Chang.